So again, the title of section 1.6 is solving other types of solutions. Your directions say exercises 1 through 10, solve those by factoring, then use the zero product principle. So they're going to help you out a little bit. In the first set of problems in your homework, they're going to actually tell you that these problems can be solved by factoring. Again, there are other types of equations, so they're not something that we've solved before. This equation is not quadratic because a quadratic equation has a highest exponent of 2. So this would not be a quadratic because I have an x to the fourth. But sometimes, even though I don't have a quadratic equation, I can solve the equation by using some of the same techniques that we did with solving quadratics, like factoring. Okay? So this problem can be factored. It's a binomial. And I notice that there is a GCF. Anybody know what the GCF is? 5x squared. Okay? So I'm still factoring. If I can factor out the greatest common factor, I'm still factoring, and the directions are asking me to factor. What am I left with when I factor out 5x squared? X squared minus 4. And if you wanted to, you could actually keep factoring here because x squared minus 4 is called the difference of squares. We could bring down the 5x squared. X squared minus 4 factors into two binomials. What are they? X plus 2, x minus 2. And then everything is set equal to 0. That's good because when we factor and we get a bunch of factors that multiply to be 0, then we can take each one of those factors, and this time there are 3. You have 3 factors here, so you're going to set all 3 factors equal to 0. So you're going to set 5x squared equal to 0, and we'll solve that in just a minute. You're going to set x plus 2 equal to 0, and we'll solve that. And then you're going to set x minus 2 equal to 0. I'm going to go ahead and tell you how important the degree of your equation is. Your degree is your highest exponent, okay? Your degree tells you how many solutions you should have at the end of your problem. So if your highest exponent is 4, that means the degree is 4. You should have 4 solutions when you get to the end. Okay, so let's take the first equation. 5x squared equals 0. We're going to divide both sides by 5, and we're going to get x squared is equal to 0. Then we're going to take the square root of both sides, and we're going to get x is equal to plus or minus square root of 0, which is 0. So usually in this first equation, we get 2 solutions, all right? But in this equation, the discriminant, or the number under your square root, is a 0. So 0 is neither positive or negative. So you won't write plus or minus 0, okay? If you're doing something like this and you get plus or minus 0, you're just going to say 0. So that's really 2 solutions there, okay? Plus and minus 0 really represent 2 solutions, but they're the same number, and that's why we just get 1 solution there. X plus 2 equals 0 solves out to be x is equal to negative 2. X minus 2 equals 0 solves out to be x is equal to positive 2. So when you check in the back of the book, they're going to say the solutions are negative 2, 0, and positive 2. They'll probably write them in order. I don't care if you write them in a little fancy set symbol. Just circle your 3 solutions. Now back to the 4. The 4 means you should have 4 solutions. But do y'all understand how this 0 is really 2? It's positive and negative 0. So that's really like 2 solutions, and then you have the negative 2 and you have the positive 2. So in the end, your solution should match your highest exponent. Okay, so we're solving that one by factoring. Number 6 is also solving by factoring. We're going to look at number 6. So I can tell from the beginning of the problem, once we get it written down, I'm going to ask you what the highest exponent is. That's the same thing as asking you what the degree of the polynomial is. So what's the highest exponent that you see? X cubed. So that the degree is 3. This is a third degree equation. That means it should have 3 solutions. And again, they're asking us to factor here. So if we factor, we want one side to be equal to 0. So we always want to go to the side where the highest degree term is positive. 9x cubed is the highest degree term. It's going to stay on the right-hand side. We're going to move everything else over, and we're going to have 9x cubed plus 9x squared minus x minus 1. And again, your directions are telling you that all of these can be solved by factoring. So thinking back to factoring, GCF, binomials, trinomials, and grouping, this one is going to be grouping. Why do we know it's going to be grouping? I have 4 terms. And when we have 4 terms and we're factoring, we usually group the first 2 and the last 2. What's the GCF of the first 2? 9x squared. And what do you get when you factor out a 9x squared? X plus 1. So we want our other group to also be x plus 1. So now you have to ask yourself, what can you factor out of a negative x minus 1 that'll give you a positive x plus 1? A negative 1. All right. Then we factor out our group. So we can factor out the x plus 1, and we're left with what? We're left with 9x squared minus 1, and we can actually keep factoring because 9x squared minus 1 is the difference of squares. So it factors into 2 more binomials, and what are they? 3x plus 1 and 3x minus 1. So once you've factored as far as you can factor, we're going to use the 0 property principle. We got all those 3 things that multiply to be 0. That means each one of the terms could be equal to 0. You'll get 3 little equations, and then you'll solve each one of those for 0. X plus 1 equals 0 gives us x equals negative 1. 3x plus 1 equals 0 gives us x equals negative 1/3. 3x minus 1 equals 0 gives us x equals positive 1/3. So again, we knew to begin with, before we ever got started here, if the highest degree term was a 3, then we should end up with 3 solutions. 3 solutions. All right, let's look at one more that's factoring. Any questions about number 6? So again, your directions say solve each equation by factoring. If we're going to factor, we have to have all the terms on the side where the highest degree term is positive. So we're going to bring the 81 over, the 81x over, and it's going to become negative. So to get ready to factor, one side has to be equal to 0. And then I see a GCF of 3x. When I factor out a 3x, I'm left with x cubed minus 27. Does that make sense? 3x times x cubed is 3x to the 4. 3x times negative 27 is negative 81x. Okay, they're asking me to factor, so I'm not finished factoring. What's x cubed minus 27 called? The difference of cubes. Oh, the dreaded difference of cubes. That factors into a binomial times a trinomial, and it is a formula. So the first part of that formula says take the cube root of x cubed, which is x, take the cube root of negative 27, which is negative 3. Then it says take your x and square it, take your sign and change it. So you had a minus sign in your binomial, you change that to a plus, then you do 3 times x, and you don't double in this formula, so you just get a 3x, and then you square your negative 3, and you get a positive 9.
How is it x minus 3 not x plus 3?
Why isn't it x minus 3 times x plus 3? Because that's not the difference of 2 perfect squares. It's not x squared minus 9 that you're factoring. It's x cubed minus 27.
Okay.
It's the difference of cubes, not the difference of squares. All right, so if y'all thought, oh, factoring was 2 weeks ago, I won't ever have to factor again, you're going to have to factor and factor and factor till you take your last math class in your life. It never goes away. Okay, so the only thing I could possibly factor again is that trinomial, but I told y'all something about the trinomial that you get from sum and difference of cubes. It will never factor. Somebody just whispered that and they were correct. So now you have to take, you just have 3 factors, okay? We have 3 factors here. I'm going to underline them. You have to take each one of those and set them equal to 0. Okay, so we have 3x is equal to 0. That won't be bad. We have x minus 3 is equal to 0. That won't be bad. But x squared plus 3x plus 9 is going to be worse than the other two. So let's just do the first two. If 3 times x is equal to 0 and we divide both sides by 3, x comes out to be 0. If x minus 3 is equal to 0, then x comes out to be 3. Okay? The last factor is a quadratic because of the x squared. We've already determined it will not factor. The trinomial that comes out of the sum and difference of cubes won't factor, so your other choices are complete the square. Does that sound like a good idea? Look at the equation. No, why is completing the square not a good idea? 3 is not divisible by 2. So what's our only hope here? Quadratic formula. Okay, so we're going to have to solve the last one by the quadratic formula. It hurts. Sorry, guys. Sometimes my job is not fun, but I'm trying to prepare you for other math classes. So you have negative b, that's a negative 3, plus or minus, under your radical, you're going to have 3 squared minus 4 times 1 times 9, all over 2 times 1. So figure out what your discriminant's going to be and tell me what you get. Negative 27. Anybody disagree? Negative 3 plus or minus the square root of negative 27 over 2. Can I stop there? No, I can't stop there. I've got to pull out the negative as an I. And I also know that what number goes into 27 that is a perfect square? 9. So I'm going to pull out the negative as an I. I'm going to think about 27 as 9 times 3. And then what happens next? It'd be all over 2. So you'll get negative 3 plus or minus 3i square root of 3 all over 2. And that really represents 2 answers. Okay, why does this represent 2 answers? Because of the plus and the minus. So remember, if we go back to our original exponent, our highest exponent is 4. That means you have to get 4 solutions. So 0 is one solution, 3 is your second solution, and then negative 3 plus or minus 3i squared root of 3 over 2 is your third and your fourth solution. Okay?
Just thinking about it makes me want to laugh.
Sometimes you have to laugh so you don't cry. So, just for you can see where we're headed here, this is not a parabola. If we graph 3x to the 4th equals 81x, it's not a parabola because a parabola has the highest exponent of 2. So this is a curvy graph. I like to call it a roller coaster graph, and we'll talk about the graphs later. But just so you can kind of see, this graph of your equation, which they're not asking you to graph, I just want to kind of get a picture, is going to cross the x-axis twice at 0 and 3, and then it'll have some type of another little curve in it. Okay? And we'll study these graphs later. Right now we're actually just finding their solutions. And remember, solutions of graphs are really where the graph crosses the x-axis. You're going to have to kind of start to make that connection. Alright, the next set of directions say, solve each radical equation, check all proposed solutions. Solve each radical equation. So the directions are going to change, and they're not going to ask you to factor here. They're going to ask you to solve the radical equation. So my first example I've picked is number 12. These are not so bad. They sound bad. Well, they're just radical equations because they have a radical in them to begin with. All right, when it says check all answers, anytime you have a radical, you want to write this over to the side. We do not want anything under the radical that is negative, okay? We do not want anything under the radical. Once we get our x at the very, very end, once we get our x, we're going to take it and we're going to plug it back in, and we're going to make sure that the left-hand side is equal to the right-hand side. And sometimes our x's do not check when we have radicals in the original equation. So we really need to check here anytime we have a radical. All right, so the first thing that I'm going to ask you is, would you consider the radical by itself? Okay, there's nothing being multiplied out in front of the radical. There's nothing being added out to the right or subtracted. So if that radical is completely by itself, you're going to remove it by squaring both sides. That's the opposite of a square root. If the radical's completely by its little lonesome self, you just square both sides. Squaring a square root makes the square root symbol go away, and you're left with 20 minus 8x, because the square canceled out the square root, is equal to x squared, which is x squared. So magically the square root goes away by applying a square to it, because those are opposite operations, and then this becomes a quadratic equation. Once you square both sides, it is a quadratic because of the x squared, so you're going to move everything over to the right-hand side, and then you're going to use your skills that you learned from section 1.5. Do you think that trinomial will factor? Signs are different. 1 and 20, 2 and 10, 4 and 5. 2 and 10, good job. 10 has to be positive and 2 has to be negative, and then we take each one of our factors, we set them equal to 0, and we get a negative 10 and a positive 2. Now they warned us, it says check your prospective answers. We think there are answers, but they have to check in the original problem. So let's try the negative 10. If we go back into the original problem, we're doing 20 minus 8 times negative 10. Negative 8 times negative 10 is positive 80, and 80 and 20 combine to be 100. So we end up with a square root of 100 on the left, and then we have an x on the right. Well, that means there's two x's in that equation. In the place of that x, you're supposed to put in what? Negative 10. We're checking to see if negative 10 is a solution. Okay, so I put the negative 10 in the left and got the square root of 100. I put the negative 10 in the right of the original problem, and I got a negative 10. Well, when you're just asked what the square root of 100 is, we're not taking the square root of both sides here. It just says what is the square root of 100, and that answer is always positive. Okay, so if you put the negative 10 back in, you get 10 on the left is equal to negative 10 on the right. So the negative 10 does not work. So you have to throw it out. It's not a solution because it doesn't check. All right, let's check the positive 2. 8 times 2 on the left is 16. 20 minus 16 is 4. So we're going to end up with a square root of 4 on the right. And we're going to end up with just a 2 on the, a square root of 4 on the left, excuse me, and we're going to end up with a 2 on the right. And if somebody just says, what's the square root of 4, you're going to always answer positive 2. So when x is 2, the left-hand side does equal the right-hand side, so our only solution there is 2. You could have had two solutions if they would have both checked. If neither one of them checked, then your answer would be no solution. Okay? So maybe you want to write something on your notes that say, anytime there is a radical in your original problem, you must check your answers. Anytime there is a radical in your original equation, you must check your answers, because sometimes with a radical, one or both of your answers will not check. And it's usually the negative one. Usually, not always, but usually it's the negative one that won't check. All right, 16. Same type of problem. We have a radical in our equation to begin with. And you're going to ask yourself, is it by itself? Is it all by itself? Is there anything being multiplied times that square root? Is there anything being added to that square root? It's all by itself. So when it's all by itself, you're going to remove the square root by squaring both sides. You're going to remove the square root by squaring both sides. So when you square the square root of 6x plus 1, the square and the square root cancel, and you're just left with 6x plus 1. This is where about half of you have forgotten how to square a binomial. What's the shortcut for squaring a binomial? Square double square. So that's going to give me x squared minus 2x plus 1. Okay? And then you're just going to solve. So let's do a squiggly line. You're going to be able to factor this one. And we're going to get x is equal to 0. And we're going to get x is equal to 8. We already know how to solve a quadratic. I'm not going to take time to do that. All right. We'll 0 check. Take your 0 and go back into the original problem. What is 6 times 0 plus 1? 1. So I have the square root of 1 on the left, and on the right, if I put a 0 in, the original problem was just x minus 1 on the right, so 0 minus 1 is negative 1. 0, if x is 0 and you plug it in on the right, you get 0 minus 1. So is the square root of 1 going to be equal to negative 1? No, the square root of 1 is 1, and that's not going to be equal to negative 1. So you throw the 0 out, and then you try the 8. Plug it in the left-hand side. 6 times 8 is 48. 48 plus 1 is 49. So you have a square root of 49 on the left. On the right, you just have x minus 1. So that'll be 8 minus 1, which is 7. Is the square root of 49 going to be equal to 7? Yes. So you just have one solution. No way for me to tell you how many solutions you'll have because you started with a radical. So there's no definite rule there. You just have to solve it out. Most of these come out to be a quadratic. The ones that start with square roots, they start out to be a quadratic, and you know how to solve quadratics. You just got to check your answers there. All right, how do these problems get harder? They get harder when there are 2 radicals in the problem. So 26, you have 2 radicals in your original problem. So when you have 2 radicals, you're going to go any, mini, miny, mo. It doesn't matter which one you pick, but one of them has to stay all by itself on one side. Okay? And in this problem, you can move the square root of 2x minus 3 over to the right and keep the negative square root of x minus 2 on the left. But one of them's got to move over because you just want one square root by itself. So I would move the one that is negative. That's just would be my choice. So I'm going to leave the square root of 2x minus 3 on the left. And I'm going to move the minus square root of x minus 2 over to the right-hand side. So that's going to look like this. 1 plus, because it was negative on the left, and you move it over to the right, then it will become a positive. So you want one square root. If your problem has 2 square roots in it, you want one square root to be by itself. Okay? Then you can remove one square root at a time by squaring. So we're going to square both sides. What do I get when I square the square root of 2x minus 3? I just get 2x minus 3, and believe it or not, I'm going to square double square on the right-hand side because I have a binomial squared. So I'm going to take the first term and square it. 1 squared is 1. I'm going to multiply the 2 terms together. That gives me 1 square root of x minus 2, and I'm going to double that. So that's going to give me 2 square root of x minus 2. And then I'm going to square the last term. And when I square the square root of x minus 2, I just get x minus 2 because the radical will go away. So this is your square, this is your double, and this is your square. These are not nice. Again, not a fun part of my job, but I have to teach you how to do these. So we're going to clean up the right-hand side. The 1 and the negative 2 combine to be negative 1. Here you have a 1 and a negative 2. And then all you can do is just write everything else down. None of those are like terms. You have that plus x. So now your job is to get this square root You have one square root left in your answer. It's that square root of x minus 2. So you've got to get that square root of x minus 2 that I boxed up. You've got to get it completely by itself. So you've got to move the negative 1. You've got to move the 2 times the square root of x minus 2. And you have to move the plus x. So let's just start. How do I move that negative 1? You add it to both sides. So that's going to give me 2x minus 2. Okay? And then I'm left with 2 times the square root of x minus 2 plus x. How do I move the x? Subtract x. That's going to give me 1x minus 2 is equal to 2 times x minus 2. And then finally, I almost have the square root of x minus 2 by itself. I've got to move the 2 times the square root, so I have to divide by 2. So you're just using algebra. I know this one's hard. You're using algebra to get that last square root because you had 2 square roots. You're getting that last square root by itself. So you've got x minus 2 over 2 is equal to the square root of x minus 2. Now you're going to square both sides. You're going to square the top. That's a binomial squared, so you're going to use your shortcut. You're going to square double square. You're going to square the top. That's square double square. You're going to square the bottom. 2 squared is 4. What happens on the right-hand side when you square the square root of x minus 2? You just get x minus 2. Okay? And finally, all the radicals are gone. Okay? We're solving this equation. What do you suggest that we do next? Multiply by 4. So that's going to give me x squared minus 4x plus 4 equals what? 4x minus 8. And then I'm left with, believe it or not, a quadratic equation. You have the x squared, so you want to move everything over to one side and set it equal to 0. So you're going to end up with x squared minus 8x plus 12 is equal to 0. That's going to factor into x minus 2 times x minus 6, which will give you 2 solutions of 2 and 6. Then you would have to check in the original problem. Okay? So I have circled both of those. Okay? They both check. I know, hopefully, that you know how to check. Both of those check. All right, let's talk about one other problem. The last part of your homework, you will have some exponents that are fractions. Okay? So let me actually set up 2 here. Y'all hang on. I'm going to do two more examples. So if I have x to the 3/2 is equal to 27, and they're asking me to solve this equation, which is not a quadratic. Remember, this is the other equation section. And you have x to the 3/2. Well, I can remove that 3/2 and solve for x by raising the left-hand side to the reciprocal of your exponent that's a fraction. So what's the reciprocal of 3 over 2? 2 over 3, right? Please tell me, y'all. I know y'all done some really hard stuff, but you know the reciprocal of 3 over 2 is 2 over 3. If I raise the left-hand side to 2/3, then I also have to raise the right-hand side to 2/3. So anytime you're solving and your x has an exponent that's a fraction and you want to get rid of the fraction, you just raise that x to that fraction's reciprocal. Because we have a power to a power rule, which says 3/2 has to be multiplied times 2/3, and that's why we're doing the reciprocal, is because when I multiply, the 3's and the 2's will cancel, and you'll just get an x. And then on the right-hand side, you have to remember that 2 represents your power, and 3 represents your index. What do we do first, power or index? We do the index. So that says the cube root of 27 is 3, and 3 raised to the second power is 9. Okay? Then you would check your answer because 3/2 is really a radical. Okay? The over 2 part, if you have something as your index, so if you go back into the original problem, would that check? Would it check? Is 9 to the 3/2 going to be equal to 27?
Yes.
Yes, because the 2 means take the square root of 9, which is 3. 3 to the 3rd power is 27. Okay? All right, so I'm not going to do another example, but the last part of your homework, you'll have some exponents that are fractions. You'll get that value by itself. You'll raise both sides to the reciprocal of that original exponent. You'll work it out, and you'll check your answer.